Now we will study refraction of light through a rectangular glass block. So I have considered a rectangular glass block ABCD of thickness T, where a ray of light traveling in air, which is PQ, strike the surface AB of the slab. Now we can say for path PQ, it is traveling from air to glass. So the ray is traveling from air to glass, that means it is traveling from rarer medium to denser medium. It gets refracted on the surface and the refracted ray will bend towards the normal. So I have considered QR as the refracted ray. But you can see for the path QR, it again hits the another surface CD and it comes out of the glass slab. That means for path QRS, the ray is traveling from glass to air. That means it is traveling from denser to rarer. So definitely the refracted ray will bend away from the normal. So here RS being the refracted ray on the surface CD, it will bend away from the normal. So whenever refraction takes place through a rectangular glass block, remember there are two refracting faces, AB and CD, and on surface AB, whenever refraction takes place, the ray travels from air to glass, that means the refracted ray will bend towards the normal, and on the surface CD, the ray is traveling from glass to air, that means the refracted ray will move away from normal. So if I talk about surface AB, for surface AB, the ray is traveling from air to glass. PQ is the incident ray from the figure. QR as the refracted ray. An angle made by PQ with normal, I will take it I. So the angle of incidence in this case becomes R. An angle of refraction here I will take as R. Right? So for the refraction taking place on the surface CD, this QR will act as the incident ray and the ray is traveling from glass to air. So QR being the incident ray, so RS will become refracted ray. And in the section of principle of reversibility of light, we studied that if a ray is traveling, let's say traveling from air to glass with angle of incidence I and angle of refraction R. Ray is traveling from air to glass with angle of incidence I and angle of refraction R. And if at some point, if we reverse the path of a ray, then the ray will retrace its path. So while going from glass to air, R becomes the angle of incidence and I becomes the angle of refraction. That means if ray travels from air to glass with angle of incidence I and angle of refraction R, if the same ray travels from glass to air with the angle of incidence R, then the angle of refraction has to be I. Here we can see that if this is the angle of refraction R, by geometry, you can say by alternate angle property, this angle will also be equal to R, because for rectangular glass slab, the refracting surface AB and CD will be parallel to each other. The normal drawn on such surface will be parallel to each other. By geometry you can see if this angle is R, by alternate angle property this angle is also R. So for the path QRS, the ray is traveling from glass to air, incident ray is QR, refracted ray is RS. If angle of incidence is R, then the angle of refraction will be I. So this angle has to be I. Now we can see that the ray RS comes out of the glass slab. So the ray RS is called as the emergent ray. So in the entire figure you can say PQ as the incident ray, QR as the refracted ray and RS as the emergent ray. And the angle made by emergent ray with normal is called as angle of emergence, which is numerically equal to I. That means whenever a ray of light passing obliquely through a rectangular glass block, what do we conclude? That angle of emergence is equal to angle of incidence. You have to remember this. Whenever a ray of light passing obliquely through a rectangular glass slab, angle of emergence is equal to angle of incidence. We can also see that the emergent ray RS is in the direction of the incident ray PP dash. That means the emergent ray and the incident ray are parallel to each other. So we draw two conclusions from this case. Whenever a ray of light passing obliquely through a rectangular glass slab, the angle of emergence will be equal to angle of incidence, and the emergent ray will be parallel to incident ray. We can see the direction of the emergent ray and the incident ray are same, so the angle of deviation in this case will be 0. But we can also see in the figure that the emergent ray is, can I say, is gets shifted, the ray gets shifted laterally. So this perpendicular distance I am considering RT, it is denoted by delta x. So here RT is called as the lateral displacement. That means a ray of light passing obliquely through rectangular glass slab will definitely travel parallel to the incident ray, but only difference is that it gets laterally shifted, वो side में shift हो जाता है, and RT here is called as the lateral shift, or you can call it as the lateral displacement. So if I talk about the factors on which the lateral displacement depends, so let's talk about factors affecting lateral displacement. So first factor is the refractive index of material of slab, and here the lateral displacement del x is directly proportional to refractive index. So remember, greater the value of refractive index, greater will be the lateral shift in that case. So lateral shift is directly proportional to refractive index. Second factor is the angle of incidence. Angle of incidence, and here lateral shift is also directly proportional to angle of incidence. That means greater the value of angle of incidence, greater will be the lateral shift. Third factor is the thickness of slab. Thickness of slab, and here lateral shift is also directly proportional to thickness. So the greater the thickness of the rectangular glass slab, greater will be the lateral shift. And fourth factor is the wavelength of light. I am talking about color of light, and here lateral shift is inversely proportional to wavelength. Remember, we have already studied that refractive index is inversely proportional to wavelength. So in this chapter, if any factor depends on the angle of refraction, then it has to depend on wavelength. So we can see that lateral shift is directly proportional to refractive index. So the lateral shift has to be inversely proportional to wavelength of light. That means for white spectrum, the red light has the maximum wavelength. So the lateral shift will be least for red color. Remember, greater the wavelength, lesser will be the lateral shift. And for violet color, the wavelength is minimum, so the lateral shift will be maximum. So you have to study the four factors on which the lateral shift or the lateral displacement depends. It depends on the refractive index of material of slab, which is directly proportional. It depends on the angle of incidence, directly proportional. It depends on the thickness of slab, directly proportional. And it also depends on the wavelength of light, that is color of light, and it is inversely proportional. That means for different color, the shift will be different. That means for red color, the wavelength being the maximum, the shift will be least. For violet color, the wavelength will be minimum, so shift will be maximum. If I give you special case in this topic, so special case will be a ray of light incident normally on a rectangular glass block, or a ray of light passing through a rectangular glass block kept in a denser medium. So if I talk about a ray of light, what if ray is incident normal to surface? So here we have got two refracting surface AB and CD. For this surface, the ray is incident normally. We have already studied the rules for refraction of light. So for normal incidence ray, the ray goes undeviated, right? Here angle of incidence is 0, angle of refraction is 0. Here also the ray will be normal to the surface CD, so it goes undeviated. So here the angle of refraction is 0 and the angle of emergence will be 0. So what we studied that whenever a ray of light is incident normally on the surface of the glass slab, the emergent ray definitely will be parallel to incident ray. The angle of emergence will be 0 because the angle of incidence is 0. Angle of deviation will also be 0. The only difference is that the lateral shift will be 0 in this case. Whereas if we talk about a ray of light passing obliquely through rectangular glass block, there will be some lateral shift. So remember, if a ray of light is incident normal to surface, what is the common thing? Angle of emergence will be equal to angle of incidence. Emergent ray will be parallel to incident ray and angle of deviation will be 0. But remember for normal incidence the shift will be 0, and for obliquely the shift will not be equal to 0, and the value of shift geometrically from the figure has been derived as t sine I minus r upon cos r. This is just a mathematical formula. Your syllabus don't have any numerical on this topic. This is just derived from the figure which we studied earlier. So the lateral shift is also given by t sine I minus r upon cos r. This is just a mathematical relation. There can be a special case where a slab is kept in a optically denser medium. So now you have to consider that a ray of light is traveling. Now this will be the denser medium and now this will be the rarer medium. So you have to be very careful. Now a ray of light passing obliquely will bend away from the normal for the first refraction, okay, and for the second refraction it will bend towards normal. So you have to draw diagram very carefully. That means in the first case we studied that this glass was the denser, air was the rarer, so there was some lateral shift. And here in this case, if glass is kept in a particular medium where glass is optically rarer than the surrounding medium, so the ray will bend. If the bending will take place like this, so first it will bend away from the normal, and in the second refraction it will bend towards the normal. Here for the first refraction it will bend towards the normal, it will bend away from the normal. So in the question, read carefully that a glass is kept in a denser medium or a glass is kept in a rarer medium. Thank you.